It's nice to see all of you here. Thank you so much for coming at this early morning session, beating Uber, beating lines after a great concert yesterday. You're all lucky because you're in one of the best sessions at Next. Hey, love the cheer. In this session, we're going to talk about data exfiltration and how we can prevent it with our Google Cloud's built-in controls. All right. I have a few partners presenting, which makes this a jam-packed session. Florence Stingasiu, who's a product manager at Google, will follow me. Then I'm really happy and honored to say we have two esteemed customers with us, Jonathan Wentz from Charles Schwab and Stephen Kreis from Commerzbank. Post our discussions, they will talk about their implementation experiences with the set of controls we're talking about. With that said, my name is Sriram Balasubramanian. I go by Sri. I am one of the product managers in Google. So what's our session like? As I told you, it's a jam-packed session. We have 45 minutes. We want to try and keep 5 minutes for quick Q&A. So how we're going to organize this is, we will start with a brief introduction around exfiltration for those of you who are trying to understand why this is becoming more and more important. And then we'll talk about Google's controls that we have, and we have a stack of controls around it to holistically prevent exfiltration from happening. We'll walk through it, and then we'll hand it off to our customers to talk about their experiences. With that, the word data exfiltration, it's overused. For all intents and purposes, it's a form of data theft that happens on your assets through a cyber attack. What's important to think about is, why is data exfiltration more and more important? And I'll start with a brief data point that I just got. Are anybody familiar here with the Google Threat Horizon reports, or GCAT as they call it? Okay. So our most recent 2024 GCAT survey actually says that data exfiltration is being prioritized more and more by attackers over data encryption via ransomware or via stolen advertisements. And they are seeing this trend continuing. This is because they find that this is extremely lucrative for the attackers to go after. So fundamentally, the cost of an exfiltration is high. I mean, the motivations for an attacker to do this are varied. It's not just monetary. We also know that there might be goals around reputation damage to the company that they want to do, or it could just be some smart person wanting to make this an intellectual challenge. All said and done, the cost of exfiltration continues to grow. There was a recent example of a semiconductor manufacturing company that had like a $70 million cost associated with an exfiltration that happened. But what makes this even more complicated is detecting this is difficult, because it starts with a breach, and that breach can eventually lead to an exfiltration when you're not looking. Cloud adds another layer of complexity. First, because the way cloud is set up, it's a shared responsibility model that not everybody fully understands. And more importantly, with high bandwidth networks available, anybody can anywhere very quickly exfiltrate bulk volumes of data via, say, APIs. On top of this, new avenues of attacks in the cloud, like phishing, insider risks, credential threat, etc., make preventing data exfiltration a much more complex problem to address. We within Google are very well aware of this. And we have looked at this holistically and looked at this as part of a defense and depth solution that you need to offer or you need to set up in your environment. So looking through it in a little bit more, if you look at your cloud assets, it's not just the resources and networks that are in question, but it also involves the devices that you're using to access them, as well as the identities involved. So these different vectors, these different assets lead to a variety of attack vectors, and we have a holistic set of solutions around it. I will spend my time talking about VPC service controls, and I'll hand it off to Florence to talk about the rest. With that said, VPC service controls. VPC Service Controls is Google's data exfiltration solution focused on preventing data exfiltration from Google services via APIs. Now, that's a mouthful, but it addresses a problem that is very unique. API-based exfiltration leads to a large volume of data exfiltration that can happen very quickly. And when you're trying to prevent it with Google services, there are not many other external technologies that can help you achieve that, which is why VPC SE plays a unique role in your security stack. Let me kind of explain this with a quick diagram. Think of Acme Org. Okay, think of Acme Org. They have all the right IAM policies in place. They also have sensitive data that they have a compute engine that's sanctioned to access, only allowed to access. But they do have other resources, including unsanctioned compute engines that do other things. But they don't have access to this particular data set. Unfortunately, as we all know and have experienced at some level or the other, identity compromise can happen. A key can potentially get stolen. And as soon as the key is stolen, the unsanctioned engine, if it uses the same key, can now access this sensitive protected resource. This is precisely what VPC SE wants to address. How do we do that? VPC SE operates as a resource-centric control. What it allows you to do is to create a boundary, a virtual boundary, around all the resources and sensitive that you deem, and services that you deem sensitive, and it prevents any data that crosses the boundary from happening without explicit sanctioned rules. All the resources within the boundary can communicate with each other, so you don't have to go manage any of them. What is supposed to work will continue to work. What isn't supposed to happen is any access that crosses these boundaries. But if there is a legitimate need to allow such an access, you can sanction it through what we call ingress and egress rules. Now, VPC Service Controls also offers a lot of other sophisticated capabilities, including things like VPC accessible services that can allow you to explicitly set which particular GCP services your VPC can actually access. And you can use this effectively in terms of preventing exfiltration that happens in case of an identity compromise, as an example. But VPC Service Controls is something that's been around since about 2020. We've had a lot of customers use it, and many customers call this foundational. So in terms of defense in depth, in forms of having multiple forms of controls, VPC Service Controls works effectively with your network-based, other network-based controls or your IAM controls, and so on and so forth. The point I want to also say is, we are continuing to invest and develop this further as we hear more needs from our customers. We focus on a variety of areas that we call pillars around where we want to invest in evolving VPC SE. And this comes from feedback from customers like you. So there are 4 main pillars that we target. The first one being what we call flexibility of perimeter creation. So far, you have the ability to create VPC perimeters by grouping a bunch of projects together. We are now extending it to VPC networks as well. So you can have more micro perimeters as if there is a need around just VPC networks and not have to have the entire project added in. On the granularity bucket, we've had a lot of feedback around having more capabilities around ingress-egress rules, especially when access crosses perimeter boundaries. So in preview, in probably a month or so, you will have the ability to use identity groups directly in your ingress-egress rules. You don't have to specify principals anymore. What's in preview today is the ability to use your private IPs, your RFC 1918 IPs that is in your organization to set up these ingress-egress rules. Now, obviously, VPC SE protects Google services, and so service coverage is extremely important. We worked really hard on it. Very happy to say we are north of 90% covered in all of GCP services. We'll probably get to 100% pretty soon. And it's an incredible effort from our teams to make this happen so far. We've also mandated that new services support VPC SE at GA. There are very rare exceptions to that we will allow, and it's going to be very hard to get such an exception for any service within GCP. So it's a strong partnership. Service teams understand that this is an important security control that they need to build to go GA, and the voices of our customers have made sure that they hear it from all other sources as well. Finally, the fourth pillar is a pillar that I am very excited about. I feel VPCSE needs to continue to evolve to make it more manageable and easy to use. So we are focusing on different areas of ease of management. To begin with, we have a new API out that you can just query to see if a particular GCP endpoint supports VPCSE or not. It's a query that you can do, and you can handle this programmatically. With that, I want to hand it off to Florent to talk about some of the other exciting things that are coming along in the GCP world. Thank you.
Thanks, Sri, and hi, everyone. I'm Florence Tangachu. I'm a product manager here at Google, and I'm excited to be here on stage today to talk to you about various controls that we have, including organizational restrictions. Sri talked to you today about how you can use VPCSE to protect your networks and your resources from various data exfiltration threats. I want to talk to you about how you can manage various data exfiltration risks associated with traffic originating from managed devices through organization restrictions. Let's take a look at a scenario. Imagine you're Acme. Acme is a name of a fictional company. And all Acme employees use corporate managed devices in order to access Google Cloud. It's very common in this kind of scenario, for all traffic originating from these managed devices to traverse through a proxy so as to enforce various restrictions on internet traffic and various different firewall policies, et cetera. Now let's imagine that we have a malicious insider, an employee, who's looking to exfiltrate data out of Acme. Well, they could use their managed device, sign in with their corporate identity, access the Acme GCP organization, and then they could download Acme-sensitive data to their managed device. Now, at this point, they're looking to actually upload that data to an organization under their own control, right? This rogue GCP organization you see there. And today, they can do so they can sign in with their corporate identity, they could use their Gmail account, and they can simply just upload data there. Organization restrictions was specifically designed to mitigate this data exfiltration path. Effectively, it's leveraging this customer-managed egress proxy layer, such as to allow the introduction of a new header that we've introduced. It's called the organization restriction header, Google allowed resources effectively. And now the contents of this header define a set of authorized GCP organizations. The security administrators of Acme can configure this proxy layer to insert this header for all Google Cloud-bound traffic, which contains that list of authorized organizations. And whenever Google Cloud receives a request, we take a look for this header. And if the header is present, we evaluate the resource that's being part of the actual request. And if the request contains a resource which is not part of the authorized organization list, we deny that request entirely. If we go back to our original scenario, imagine Acme security admins have adopted this feature. They've set up their ingress proxy layer to insert this organization restriction header that specifies only the Acme GCP organization as the authorized GCP organization that can be accessed. When the malicious insider is looking to actually perform the data exfiltration to the rogue GCP organization, that request will be denied, since the rogue organization is not part of the authorized organization list that's defined within the header itself. And as part of this launch for this feature, we've worked very closely with a number of our networking partners in order to ensure native integration with organization restrictions. And we're proud to highlight F5, Palo Alto Networks, Fortinet, and Zscaler as some of the solutions which natively support the configuration of organization restrictions. That being said, this actually also works with any open source or any other egress proxy solution, as long as the solution can support the insertion of a header that's customizable. And to sum it all up, organization restrictions is a useful feature in helping mitigate data exfiltration events associated with insider risks or phishing attacks, in fact, as well. But it does require the existence of that middle egress proxy layer, which has to be available in order for you to be able to configure this. What if you don't have such an egress proxy layer? Or what if you would like to potentially mitigate data exfiltration risk associated with service account traffic. That kind of traffic is typically not subject to this egress proxy layer in the middle. So as part of this, we're proud to announce principal access boundaries as a new security feature which will become available in preview later this quarter. Similar to organization restrictions, principal access boundary policies help mitigate risks associated with insider threats or phishing attacks. However, unlike organization restrictions, this is a principal-centric control, meaning that this is a policy which you can attach directly on an identity, meaning there's no need for this egress proxy layer in between. Let's take a look at how this works. And I actually want to take a phishing example in this particular, with this particular control. Imagine that there's a malicious actor, they set up this phishing organization, and of course, since they own it, they can author a policy against it that says, I want to grant access to this phishing organization to all Acme identities. Effectively, what this malicious attacker is looking to do, they're hoping that a poor Acme employee mistakes this phishing organization for the official Acme organization and mistakenly uploads Acme-sensitive data there. Well, through principal access boundary policies, the security administrators of the Acme organizations can enforce a policy on the Acme identities over there that restricts their overall set of resources access to a specific boundary. In this case, it would be the boundary of the Acme organization. And the admins can configure the resource boundary with organization, folder, or even project level granularity, so you have the most flexibility when it comes to configuring that resource boundary. And it's important to note, principal access boundary policies are restrictive. They do not grant access. And in fact, in order for access to succeed, you still need an IEM allow policy, but they're independent controls, meaning both of them have to satisfy the evaluation of a request in order for the request to succeed. And since this is a principal-centric control, there's no need for that egress proxy architecture in the middle. Now, I would like to talk about some examples. We already kind of talked a little bit about this one, which is the restricting principles to a specific organization, right? This is the control that we expect most customers to adopt in order to enforce this type of restrictions on their principals. And we recognize that as a business, you often need to collaborate with vendors, with partners, with subsidiaries, with other organizations. And principal access boundary policies makes it easy for you to extend your boundary to an organization, or in this particular example, even just a folder, just a project, in order to be more careful about how you enable this resource boundary. And while the two are mostly focused on data exfiltration mitigation, there's also other type of scenarios that can be achieved with principal access boundaries, such as the ability for you to be able to apply restrictions on service accounts in your production folder such that they can only access resources in that production folder. This is an opportunity for you to use this feature as a way to isolate identities within their specific environments. Now, I'd like to invite you to keep a close eye on our blogs and on our documentation as we get closer to the public preview in order for you folks to learn more about this. And I know we've talked quite a bit about, we've talked a little bit about this diagram. We talked about VPCSC, we talked about organization restrictions, principal access boundaries. And we strongly encourage you to evaluate all of these tools in order to determine the right security strategy for your organization. And of course, there's not one security control which you can use to mitigate all security threats. Instead, we recommend to take a defense in-depth approach, and there's plenty of other tools in GCP in order to help you achieve this defense in-depth security posture. Cloud Armor, context-aware access, firewalls, they're just a few of the overall set of controls which can help you mitigate data exfiltration and achieve this defense in-depth posture. Now it's my pleasure to introduce Jonathan to the stage from Charles Schwab to talk about how they help mitigate these risks.
Thank you, Florin. Hi, I'm Jonathan Wentz. I'm the lead GCP architect for Charles Schwab's Cloud Services organization. I also led the infrastructure as code and GitOps for cloud strategy. Because of the responsibility we have for our customers' financial well-being, we take security very seriously. The quote here is from Walt Bettinger, our CEO. "Trust is everything, earned over time, lost in an instant." We strive to ensure that cybersecurity is integrated at every level, from design through engineering and operating our cloud applications. we're driving towards a zero trust architecture, focusing on fine-grained, least privileged access, and segregating each application's environments to prevent over-provisioned accounts and cross-application impacts. We achieve this at scale with automation, ensuring that environments are built only with infrastructure as code, primarily Terraform, and following a GitOps flow, which includes security engineers and pull requests reviews. Or with on-prem systems, there are practical limitations to the size and complexity of our lower environments. However, with IAC and cloud, we can enable application teams to have consistency across their environments and allow production-like testing in lower environments without needing access to or impacting production applications or data. I'm going to start at the bottom of our foundation stack. This is a simplified view of our foundation protections. It represents the default deny items that we enforce across the board. Every project uses private Google Access, the restricted VIP that enforces VPC service controls APIs. Those are the only APIs that are called from within the projects. We have firewall policies that allow access to only restricted VIP and block access to, say, the private VIP, which will let you access things that are not VPC-SC protected. Every project in our org is part of a VPC-SC perimeter where we enforce most services. We actually require that any data-bearing service support VPC service controls before we can implement it. And last but not least, we use org policies to restrict certain actions, such as getting a service account key out, or a public IP address, or creating resources outside of the US. Moving on to the next level, this shows how we allow specific connections through from our on-prem applications or workforce and approved SaaS applications. For access from our applications on-prem to our data centers, we have interconnects. That's primarily for business application traffic. We wanted to ensure that access to those Google APIs for our on-prem applications didn't have to go through a proxy layer for their security, because that would greatly limit the scale that we have for being able to interact with those APIs. So allowing us to use the private Google Access for on-prem hosts, which enforces those same VPC service control protections, basically extending the perimeter of our data center into our cloud. For workforce members, it's a little bit more complicated. For one, the Google Cloud Console is not available on the restricted VIP, and even if it was, it wouldn't really solve the issue. We have legitimate need to access things that are not in our GCP org. There are some services that are not org-based, and there are SaaS vendors that use GCP that would be blocked if we were forcing interactive access to go over that connection. So we have an HTTP proxy, much like Flora mentioned, that has CASB and DLP capabilities for workforce browser traffic. This is where we add the org restriction header to ensure that we're only accessing the approved GCP organizations for that traffic. Whether you're using a Schwab account or a non-Schwab account, as Flora mentioned, that you could prevent an egress with someone who's logged into their Gmail account, for example. And then finally, we have VPC service control rules, which allow traffic from our known source IPs into those perimeters. It also allows us to access resources like via IIP or other services that are not on a shared VPC while blocking traffic from other sources. And that's a lot to manage at scale. So here's a simplified view of our infrastructure as code pipeline structure as it relates to environments and our application segmentation. For more details on this structure, I recommend looking at the Secure Enterprise Foundation blueprint on Google Cloud Architecture Center site. This is very much modeled after that. We have a few more perimeters than are shown here, but fundamentally we use VPC service controls today also for macro segmentation. So we have a foundational perimeter where all the shared services live, like our IAC pipelines. The foundation pipeline itself manages our org, folders, IAM, org policies, service controls, and establishes what we call the project factory pipeline. Then we have a separate perimeter for production, non-production, and development environments. The development segment is the only place where we have both human and IAC provisioned resources. Everything in the production and non-production segments are only ever built with IAC, and we require that every application have at least one environment in each segment and then promote through via GitOps. That way, there's nothing ever done for the first time in production. Each segment also has projects for segment-specific resources, such as logging, shared VPCs, KMS, and what we call external service accounts, or service accounts where you're allowed to get a service account key out. The project factory, which is shown at the bottom, creates the application projects and folders, their IAC pipelines, and any app-specific resources that are part of those shared projects, such as a KMS keys, external service account, or shared VPC subnet. Then each application has its own cloud build pipeline, which then only has access to that application's resources. And that's what then deploys the application resources in there. So it's least privilege access and then microsegmentation. And if I had a key learning for our implementation for Google Cloud, I would definitely say start with adopting VPC service controls and infrastructure as code as early as possible in your pipeline. It will definitely make it a lot easier to start with a default deny and then grant access than trying to restrict things later. And now I'll hand it over to Stefan from Commerzbank.
Hello, everybody. My name is Stefan Kreis. I'm a cloud solution architect at Commerzbank. And I also want to talk to you about how we implement cloud security with the controls we already heard about. But before looking at that, I want to briefly introduce Commerzbank and who we are. We are, in fact, the largest or the leading bank in Germany for the German Mittelstand, with around about 11 million customers in the private and small business custom area. We have a focused business model which deals around growth, excellence, and responsibility. And I want to point out one topic there, which is shaping the digital and sustainable transformation. Because in order to be able to do that, we leverage public cloud, and is a very important part of our transformation. So since we're a bank, since we're heavily regulated, since we care a lot about our customer data, only a secure cloud foundation can be the cornerstone of our digital transformation. So what we have done over the past time, when we went to cloud and adopted during our cloud journey, is we've come up and established a communication network model that allows us to mitigate, control, govern, isolation, and integration. So where we can define which servers are allowed to talk in which manner with each other, and have a much more granular control over the overall network flow. What we tend to give to the application teams is a secure by design and zero trust based architecture. So whenever application teams request project through an automation platform, they get something that is secure by default, perimeter based, lockdown. So there's no sort of playground. Everything from dev environment starting on is treated in this manner. Least privilege, of course, IAM is something that we care about a lot. What we do in order to achieve that is, of course, the same as Jonathan already mentioned, is a high degree of automation. Also for us, infrastructure as code using Terraform is at the core of all these automation topics, and we use it to build the foundation, meaning organization, resource hierarchy, perimeters, level of depth and stuff, up to the application deployment. So infrastructure as code is, again, something we enforce a lot. When we look at cloud security, although we have a multi-cloud strategy, so we have another cloud provider in our company, we are using the cloud native, the built-in security features as the primary choice to look at cloud security topics. So on GCP, it's clear we are using all these data built-in controls to ensure we have a secure cloud platform. And what we're currently looking at a lot is a cloud security posture management, where we are looking into monitoring and remediation of threats that appear from misconfigurations. So going forward, that will be a bigger topic for us as well. So on the next slide, I want to briefly talk about which of these built-in and already available security capabilities from Google Cloud we're using. At the top of that is VPC service controls. So VPC service controls is really one of the core foundational topics that we use to ensure data exfiltration cannot happen. I want to talk about it a little bit more in a second. On the other hand, we use the topics like organizational policies, where, for instance, domain-restricted sharing is a very important policy, and we're to ensure that only principals from our organization can be permissioned as in our resource hierarchy. And we're happy to see that Google is now enabling this policy by default for every new org, which is great for a secure by default setup, and we think it makes a lot of sense. In order to prevent privilege escalation and lateral movement, we have several IAM deny policies throughout the organizational policy, hierarchy, where we then control that these things cannot happen. And bringing it all together, we use Security Command Center to monitor and notify on any active misconfiguration vulnerabilities, threats, which then these topics get forwarded to the enterprise SOC, but as well to the application teams where they can look at these configuration topics. So like I said, VPC service controls is a major cornerstone of our security architecture, and here I want to briefly talk about how we are implementing it. So the initial approach we were treating it as a separation of environments. So we were putting every environment, everything that's in dev, test, production, into one bigger perimeter, allowing for them to communicate within these perimeter, a little bit like classical on-premise environment. But now going forward, when we transition to a much more service-oriented environment, we're going to transition also here to a micro-segmentation implementation, where on the right you see an example how this looks. So each application has its own perimeter, and even within this application, we separate the several environments from each other so that no data flow can happen between these environments without special configuration. So, of course, when we lock it all down, data sharing is something that applications still need to do. So we do that based on granular ingress and egress rules, where then we put in place, using automation again, infrastructure as code are also here to allow data sharing between these several environments. And for that, we're really happy that Google now will support groups on the ingress and egress rules, because today we have to do it on an identity level, which makes a lot of overhead in terms of management for us. So the key concepts here for us really, on the one hand, is no data access from outside, because we want to protect these multi-tenant APIs that everybody could reach via public interface normally, but also no data transfer from inside Commerzbank to the outside, no data transfer between the application and even between the stages. So VPC service control is, like I said, a very important part. And like Jonathan mentioned, I want to say the same thing. Adopt and look at it as early as possible, because it is something that should be there quite quickly, because it's much easier to open things up again before locking it down. If you need to do that, what we use there, and also during the transition to the microsegmentation implementation, is the try run mode. So we lock stuff down in try run mode, evaluate, look at what might this change cause for problems, and then work with the application teams to mitigate that problem. What was not on the list on the building controls is the organization restrictions, because for us, the proxy was something that is managed not by us as a platform team. The proxy is managed by the network guys, and it didn't allow us for much control over that header injection and how we are proceeding there. So therefore, we are really happy that with principal access boundaries, we're now getting a method like all the other APIs, which we can programmatically fine-tune from a platform level, from a foundational perspective, to also restrict access as part of our boundaries, so we cannot have permissions being granted to our identities in different organizations. So therefore, what we have now been testing with Google as part of our private preview involvement is, like Florin mentioned, what we're starting now is putting a perimeter around, or a principal access boundary around the organization, because we're not seeing here this need for the separation between the stages and so on. But we want to protect the organization and our identities, but this time not also the workforce people or the user identities, but also service accounts, so that they can never be permissioned in an untrusted organization. We will, and this is the good thing about it, because we also have this requirement that we work together with vendors and partners for different organizations, and that is great that principal access boundaries will allow us to granularly, like an ingress-egress rule, allow specific identities on the identity level to be able to talk to this outside organization.
We very much appreciate your time. Hope you enjoyed the rest of your conference. See you all around.